from part A. And that's it. That's the problem. I apologize. I was suffering again, so y'all don't have to. So next, we'll do the club head speed. I'm going to pause, take a quick break. I'll be right back. Okay, so let's do this long-awaited driving distance versus club head speed. Looking at the graph, we're going to have club head speed over distance. So in like seconds, you could label your variables. But if I'm just trying to put raw data in, I mean, that's not bad. That's not bad. Something like that. I think it's going to go quickly. Let's see. I can't remember what the question was. What does it want us to do? Okay, it's a way to make predictions. I think it just shows us the example. Let's just take a look at it then. What we want to do is we want to add a table. The club head speed is the independent variable, so we'll put those values in: 100, 102, 103, 101, 105, 100, 99er, and 105. Now let's go over here, 270. Oops. 275. Let me know. Let me know. I'm going to make a typo. Is that, remember, that's when you're looking for an outlier, right? The first thing you want to do is investigate further. So if I see something weird coming off over here in Desmos, then the first thing I should do is check out whether or not it matches. And there's a typo, right? So be careful on your data entries. Let's take a look at where those points end up. There they are. Look fairly linear. Yeah, got a little jumping around going on. But let's do the line of best fits. Let's go over here. We want to choose, oh, the new button. Add regression. And like I've been saying, there's many different types, right? There's many different types of regressions, the models that we could choose, and oftentimes we determine which is the best through that. But these quadratic models, but anyway, we're doing linear. And then there is our equation right there. So, and remember we get into this concept of extrapolation. So our far left point is 99er, and our far right point is 105. So within this range from 99er to 105, this is called interpolation. So let's just try a number between there. I think I was going to do 102. And that's an interpolation. There's your prediction. That's how easy that was to do the predictions. If you got a prediction problem, go to the Desmos. Remember, we're bringing in more resources to lower the amount of time spent per problem, right? And that's what we've got to do. We've got to ramp this up. Otherwise, that last sections, if you can't use the technology, it will be very, very hard. So master it now so you have a good understanding of it as we go into these further chapters, which they're gonna get pretty. So that's one thing about statistics. It starts off pretty easy. Oh, averages, standard deviation, add, subtract, square, take square. Then we start getting into inferential statistics, and that's where it gets very theoretical, and it can be complicated. So be sure to get these things down. So notice that's an interpolation because it's in between all the data values. So something greater than the far endpoint of the domain, this is extrapolation. And our textbook clearly makes the stance that you never, ever do that. Not at this level you would. let's say we have a different level. You know, maybe you're a business and you're looking for that one big shot, right? That's capitalism. I love capitalism. I'll get excited when I start talking about capitalism because it's one big shot. It's so statisticky. It's so probability. You might want to go for the big one and extrapolate, but there's dangers involved in extrapolation. And then just like this is the far left point, if I was to try to evaluate the model to the left of the far most data point, that would also be extrapolation. There's no real big gamble. If we're talking about time, I guess we're talking about, I'm not much of a golfer. I worked at a golf course in Kansas City for when I was in college the first time. But like, I don't know much about this, what that would mean. Like if you had a 90, why would that not be? I'm assuming that, well, that's an interesting. That's an interesting. Our typical average golfers club head. I was just asking, hey, we got plenty of resources here. Where's the club heads in miles per hour? So I guess we would need to clarify further, like, is it the driver, right? Is it the which one is it? One of the woods, one of the irons? What is it? But anyway, look. So female average is about right there, and those are amateur averages. Male average is 93. So that's what I'm guessing is that these are higher level golfers, slightly above. Let's try this. Let's try this one. I'll say so above average is right in here. So these are above average golfers. We just solved the mystery right there. That's what an extrapolation would be. If we were to use that extrapolation, right? Here it is. We would be in another set of golfers. That's, as we said, is the average golfer up into this range is getting into the slightly above. So these would, I don't know, does it say anything about them, or are they professionals? I don't think it says much. But anyway, there we go. There we go. A few more things to work out in your system about the linear regression. We should be able to bank now that we trust the technology to deliver its following these rules. Be careful with the variable assignment. That's what, as you saw, I'm going to leave, let it play, let you see the struggle. Because it was a complete decoding in my brain. I've been teaching college algebra, linear algebra probably for the last couple of years, and it's been at least a year or so since I taught statistics. So I had to really recode my brain, and also what I thought it was, right? With the B naughts and the B1s, now that we're renaming them. Now the y-intercept is A, and the slope is B. Oh, Lord, forgive us. Anyway, all right, I'll talk to you all later.